have our titrant and our clamp holding our bure, which we are in our waste beaker, which we're going to rinse out our bure 3 times using a 0.07 concentration of hydrochloric acid. And we're going to put our waste beaker aside for a second now that we have had our bure of free contamination by rinsing with hydrochloric acid. And we're going to introduce our stock solution of calcium hydroxide, which has been supersaturated. And we're going to take 30 milliliters of the supernatant, which we have here, and this is what we're going to use and we're going to put this in an Erlenmeyer flask, and this is what we're going to use this is where we're going to be titrating. And we're going to take our 2 drops of our methyl orange indicator, so 1, 2, and we're going to give that a swirl to mix the contents and set that aside. And we're going to, this is our bure again, and we're going to add the 0.07 concentration to the bure. And if it has any air bubbles, we're going to release the stock solutions to get it for the air bubbles to come out, and then we're going to close it back up in our waste beaker and set that aside. We won't be needing that anymore. And then we're going to put our Erlenmeyer side with our methyl orange indicator and our supernatant, and that's what we're going to be titrating. Then we will begin titrating. Now, when it has reached our solution has reached a light red orange color, that's when we know, because of the orange indicator, that's when we'll know if it's ready or not, when the titration is complete. And we're going to record our final volume of our bure, the final reading of our bure, because their initial was 30 milliliters and our final was 21 milliliters, and we're going to subtract those 2 values to get 9 milliliters, and then we're going to convert to liters, or 0.0079 liters, and that's going to be the volume of our hydrochloric acid added. Now, to find the molar solubility, we're going to take the volume of the hydrochloric acid and we're going to multiply it by the concentration of a hydrochloric acid, which is 0.07, and we're going to get the moles of hydrochloric acid. Now, we're going to use the moles of hydrochloric acid to find the moles of hydroxide, and by doing that, we use this equation, or like the basis of that, the moles of hydroxide is equal to half the moles of hydrochloric acid. So we're just going to divide the moles of hydrochloric acid by 2, and that'll give us the moles of hydroxide. Now we're going to find the concentration of hydroxide by dividing the moles of hydroxide by the volume of the calcium hydroxide in liters, and that's going to give us the concentration of hydroxide. And then we're going to take the concentration of hydroxide and we're going to divide it by 2 because of the equation that calcium, or the basis that calcium hydroxide is equal to half of hydroxide, of half the concentration of hydroxide. So we're going to take the concentration of hydroxide divided by 2, and we get the molar solubility of calcium hydroxide, which is 0.0054. Now, to find the KSB, or the solubility product, we're actually going to use this equation, or like the basis that half the concentration of hydroxide to the 3rd power is going to give us our KSB, or solubility product. Now, we're going to, into the concentration of hydroxide, we're going to plug in our concentration of hydroxide, which we see here, and we found by dividing our moles of hydroxide by the volume of calcium hydroxide, liters. And we're going to put it to the 3rd power, and that's going to give us 0.00001281, and we're going to multiply that by 1/2, or multiplying by 1/2 is all the same thing as dividing by 2, and that's going to give us 0.00000064, and that's going to be our KSB, or our solubility product. Now, all this is going to be based on, starting out with your initial and final, and the volume of the calcium hydroxide. All these values are going to be based on your titration. So from your initial bure reading to your final bure reading, to the amount added and subtracted, that's how you find their calcium, the volume of calcium hydroxide added, and all that's going to be from your data that you collect by your titration. And so that's how you're going to want to always record your data while you're doing a titration. And that's how you found molar solubility and KSB, or solubility product.